In this lesson, we discuss improper integrals. There are several types of improper integrals, and in this lesson, our focus is on the improper integrals that at least one of the limits of the integral is an infinity. Uh, Let me just as a reminder, as you know from Calc 1, part of the fundamental theorem of calculus is when we integrate a function over an interval, or when we calculate a definite integral, uh, we find an antiderivative of f of x. Let me call that capital F of x. And then we evaluate at endpoints. We'll have f of b minus f of a. So capital F is an antiderivative of lowercase f. So this is just a reminder of Calc 1. So remember that the derivative of capital F of x is lowercase f of x. But in Calc 1 and also in Calc 2, so far, a and b were real numbers. They were not infinity. But sometimes b could be plus infinity, or a could be minus infinity, or we might have both situations in one example. A might be minus infinity and b might be plus infinity. And that's where one type of improper integrals might happen, that a or b are infinity, like b could be plus infinity, a could be minus infinity, or both situations might happen in the same problem. Remember that when we had the function was positive, meaning that if the graph of the function over the interval was above x-axis, like this, y equals f of x, the integral from a to b gives us this area. But sometimes b could be infinity, meaning that uh, something like this might happen, that we have the integral from a, but the upper limit of the integral is not a specific value, it tends to infinity. Or we can have the situation that instead of a, we have minus infinity. So the graph starts from the very left end of the coordinate system. So let's first talk about the case that b is in fact plus infinity. In other words, we have the integral from some number a to infinity of a given function f of x dx. Depending on the function, sometimes the value of this integral might be a number, and in some cases it's not a number. So in fact, in this lesson, we are interested in discussing this matter and see different kinds of examples. But before that, we need a definition. How can we define this? So let me first make a definition. How can we define the integral from a to infinity of f of x dx? The way that we define that, and we use this definition to calculate the upcoming examples, is we find the limit of this integral. So I leave a little bit of space here because I want to write a limit there. I calculate the integral from that given a up to b of f of x dx. So a is a given number, but for now b just is a letter. And then I let b tend to infinity. And that's how we calculate the improper integral. But this might be not, it's not completely clear unless we do examples. So as the first example, I want to calculate the integral from 1 to infinity of 1 over x squared dx. So by definition, to calculate this, I should find the limit as b tends to infinity of the integral. In this example, a is 1, so I just write 1. But for b, I write b. And then after calculating the integral, I let b tend to infinity. So for now, forget about the limit sign and just calculate this. You will get something in terms of b because the upper limit of the integral is b. So it's natural to expect to get the value of this integral in terms of b. Let me just write the limit sign, but I don't need to apply that. So for now, antiderivative of 1 over x squared, as you know, it is minus 1 over x. This is something that you have seen even in Calc 1. And this should be evaluated at the end, the limits of the integral. Again, for now, I don't apply the limit. Let me just move forward. So the evaluation of minus 1 over x at b, which is minus 1 over b, minus the evaluation of this at 1 minus 1 over 1. Now let's tend b to infinity. When b tends to infinity, you have seen these kind of limits in Calc 1. What is 1 over infinity? When b tends to infinity, 1 divided by infinity is what? Is 0. So this fraction, the limit is going to be equal to 0. So this goes to 0. Just let me write a 0 here because 1 divided by infinity is 0. So what about the rest? Inside parentheses minus 1, there is a negative outside of that. So the value of this integral is going to be 1. So the integral from 1 to infinity of 1 over x squared dx is 1. In this example, the value became a number. If a value becomes a finite number like this, we call the integral a convergent integral. So this integral, in fact, is a convergent integral. Let me write the definition for this concept as well here. definition. If an improper integral is equal to a finite number, like in this example, that finite number was 1. At the end, we got 1. The integral is convergent. Otherwise, it's divergent. Otherwise, so if we don't get a number, it's divergent. Let's do another example. The integral from 1 to infinity of 1 over x dx. I want to calculate this. Let me make it a kind of multiple choice. So we should choose between these two. So which one is correct? A, it's convergent, and the value is this value. So if I go with A, if I calculate this and it turned out it's a number, I should choose A and enter the value that I get here. Or B, it's divergent. If I don't get a finite value, then it's divergent. So let's do that on the next page. So work on the next page. The solution on the next page. So to calculate this, the integral from 1 to infinity of 1 over x dx, it's going to be the limit as b tends to infinity of the integral from 1 to b of 1 over x dx. So for now, we don't apply the limit. We just calculate that definite integral from 1 to b. And after that, the expression that we get will be in terms of b, and then we let b tend to infinity. Do you remember what was the antiderivative of 1 over x? It is ln of absolute value of x. We don't need absolute value. Do you know why? Because we are integrating from 1 up to somewhere more than 1, and there is no negative x there, so there is no need to absolute value for x here. And then we evaluate at these numbers. So the limits as b tends to infinity. Evaluate ln of x at b becomes ln of b, natural logarithm of b. minus natural logarithm of 1. Natural logarithm of 1 is 0, right? Logarithm of 1 is 0. How about ln of b? This is something that you have seen in Calc 1, that ln of b, or logarithm of b, as b tends to infinity, is also infinity. So this is infinity. And obviously infinity minus 0 is infinity. So we got infinity. We didn't get a number. So what should we do? Go back here. We should choose B. In B, there is no space for writing infinity. If there was, in B, there was some box there saying that it is divergent and it approaches, or it is equal to, then I would have needed to enter infinity, but B doesn't have anything like that, so just it's divergent. Let's do another example. The integral from 1 to infinity of e to minus x dx equals. Now, so that's the question that we have, but let me again make it multiple choice. So which one is correct? A, this integral, the integral converges to this value. So I just enter a value here. Or B, the integral diverges. So please try this on your own and choose the correct answer. Which one do you think is the correct answer for this problem? Just in case, if you chose A, you need to enter the value, which is must be a finite number. And that finite number should be an exact value. Do not round to any any decimal place. Write the exact value of that. So, by definition, this integral is the limits as b tends to infinity of the integral from 1 to b. Just replace infinity by b, and then at the end let b tend to infinity of e to minus x dx. So for now, we don't apply the limits because first we do the integral. Do you remember what was antiderivative of e to minus x? As you might remember, antiderivative of e to the kx was 1 over k e to the kx, and of course plus c. But since it's a definite integral, we don't need to worry about that plus c. So antiderivative of e to minus x is minus e to minus x. E to minus x is like e to the power of minus 1 times x. That's why I reminded you about antiderivative of e to the power of kx. And then we evaluate at these two limits of the integral. So this becomes the limit as b tends to infinity. The evaluation of minus e to minus x at b is minus e to minus b minus the evaluation of this at 1 minus e to minus 1. So when b tends to infinity, minus b here becomes minus infinity. Look at here. B tends to infinity. Minus b becomes minus infinity. And e to the power of minus infinity is 0. So the first parenthesis is 0. Just let me remind you from Calc 1 that how the function of y equals e to the x looked like, something like this, right? This left end means, roughly speaking, is e to the power of minus infinity equals 0, because this is kind of informally e to the power of minus infinity is 0, because that the graph on the left end, when the value of the variable is tending to minus infinity, the exponential function tends to 0. Okay, so this is why e to minus infinity is 0. So that's why the first parenthesis is 0. So what's in the second parenthesis? Minus e to minus 1. First of all, those double minus times negative is a positive. So the answer is e to minus 1. And we try to avoid negative exponents in our final answer. E to minus 1 using basic algebra is 1 over e. So the value of this integral is 1 over e. It's a finite number, so it is a convergent integral, or the integral converges, and it converges to 1 over e. Now, please try this example on your own. The integral from 0 to infinity of e to the power of 4x dx. This example looks like this previous example, but it's very different because the power of e is not a negative times x. It is a 4 times x. Again, it converges to a value, or it's equal to a finite value. B, it diverges. So please try this on your own before watching my solution. Again, I use the definition. It is this equals the limit as b tends to infinity of the integral from 0 to b of e to the power of 4x dx. For now, we don't apply the limit. So the limit as b tends to infinity. Antiderivative of e to the 4x is 1/4 e to the power of 4x. I'm sorry, 1/4. 1/4 e to the power of 4x. Remember that antiderivative of e to the power of kx is 1 over k times e to the power of kx. And this should be evaluated at the limits of the integral. I mean 0 and b. So the lower limit was 0, sorry. So the limit as b tends to infinity. We evaluate that antiderivative at b, which is going to be 1/4 e to the power of 4b minus the evaluation at this at 0, which is 1/4 e to the power of 40 is 0. So when b tends to infinity, that exponent for b is also plus infinity. So when tends to infinity, 4b tends to infinity. And e to the power of infinity is infinity. So in this example, this parentheses is infinity. In the previous example, that parentheses became 0. So you see that these two examples are very different in nature. The second parenthesis is just a number, and infinity minus any finite number is going to be still infinity. So the answer is infinity, is not a finite number. So we should choose B. So the integral diverges because by this calculation, what we got here was not a number, it was infinity. Another example. Again, please try this on your own. The integral from 2 to infinity of 20 times e to the power of minus 4x dx. Again, which one is correct for this integral? Which one is correct? A, this is convergent and there is a finite number value or convergent and equal to, and I should enter the exact value of that finite number here, or it is divergent. So I want to know that which one is the correct answer. Okay, so let's use the definition. By definition, this is going to be equal to the limit as b tends to infinity of the integral from 2 to b of 20 times e to the power of minus 4x dx. So which is the limit as b tends to infinity. What is antiderivative of this function? First of all, 20 is a constant, can be pulled out of the integral. And antiderivative of e to the minus 4x. Again, let's remind ourselves that antiderivative of e to the power of kx is e to the power of kx over k. So this is e to the power of minus 4x over minus 4. and this should be evaluated at the limits of the integral. 20 over minus 4 is negative 5. So I will have the limit as b tends to infinity. This function at b is minus 5 e to minus 4b minus this function evaluated at 2 minus 5 e to the power of what? Minus 4 times 2e is minus 8. Now let's discuss the first parentheses. B tends to infinity. What happens to minus 4 times b? Minus 4 times b becomes minus infinity. And remember that e to the power of minus infinity is 0. So the first parentheses is just 0. What about the rest of this expression? Minus minus 5 is plus 5 times e to the power of minus 8. We try to avoid negative exponent in our final answer. So I need to move e to the minus 8 to the denominator. So this becomes 5 over e to the 8. This cannot be simplified more, and we want to have an exact value. So this is that exact value. So we got a finite number. So we should choose A. It is convergent and equal to 5 over e to the power of 8.